Hello there. In this video, I'm going to talk you through another type of sequence that you need to be familiar with for GCSE maths. Now, you don't need to know a huge amount about these. You need to be able to recognise them, and you need to be able to do a little bit with them, but we're going to cover all of that in this video. So the type of sequence we're going to look at now is geometric sequences. For a geometric sequence, the term-to-term rule is multiplying. You can also think about it as dividing as well, but I'm going to go on and tell you more about that in a minute. So this sequence that I've given you here is a geometric sequence. And if you look at what happens as you go along, every single time you can see we're multiplying by 3. Okay, so unlike an arithmetic sequence, the gaps between the numbers do not stay the same every time. They get bigger and bigger and bigger. And we can find a multiplication rule that jumps us along the sequence. The number that you multiply by is called the common ratio. Be really careful, it's the number you multiply by. So sometimes people get a little bit confused when they notice a division instead of a multiplication, but we're going to see an example like that in just a moment to clarify how to deal with them. The formula for a geometric sequence will have n as a power. Okay, so it might just be a number to a power, or it might be a number multiplied by a number to a power. Okay, that will get you a geometric progression. Let's have a look at a couple more examples of geometric sequences. Okay, so for this one here, you can see that to go from 900 to 300 and then to 100 and then to 33.3 recurring, we're dividing by 3 every time. Now, like most people, I notice that as dividing by 3. But in order to think about common ratio, I need to think about what I'm multiplying by. Dividing by 3 is the same as multiplying by a third. Okay. So if you were asked for the common ratio for this sequence, it would not be 3, it would be 1/3. So you always have to think of it in terms of multiplying for the common ratio. You can use the fact it's dividing by 3 if you're going to work out the next term or things like that, but in terms of giving the common ratio, it has to be what you multiply by. Okay. For this one here, as we go along, we times by 2, because we're doubling every time. Okay, so the common ratio for this one is going to be 2. There's one other thing that I'd like to point out before we try some questions, and that is, if you want to do a double jump in this sequence, you'd times by 4, which is 2 squared. And if you wanted to do a triple jump, you'd have to times by 8, which is 2 cubed. To do 4 jumps, you'd have to times by 16, which is 2 to the power of 4. So to do multiple jumps, you're going to be using powers of the common ratio, and that can sometimes help you out with questions as well. So another example, to go from 900 to 100, we're dividing by 9, or timesing by a 9th, which is 1/3 squared. Okay, so for these questions, try and find the common ratio for the sequences. If you manage to finish, have a look at these questions in the box, which ask you to try and work out the missing values. But you will probably want to think about the common ratio first in order to do that. Okay, so I'm going to talk through the answers. Hopefully you've had a chance to have a go at one or two of those questions. So here are the solutions. I just want to point out a couple of things that might make your life easier. First of all, when you're working out the common ratio, because it's the same throughout the entire sequence, you can choose whichever pair of numbers will be easiest to work with. So for example, instead of thinking about the jump from 48 to 24, you could just look at the 6 and the 3 and then see that it's halved. So some people find it easier to use pairs later on in the sequence for some questions than others. For this one here, we can see that the common ratio is 3 because to go from 0.7 to 2.1 we have to triple. So that's how we can get the one in the middle. For this one here, you have to think about the fact that when you do double jumps, you're squaring the common ratio. So you can think about going from 7 to 175. And if you do 175 divided by 7, you'll get 25. That's the common ratio squared, so the common ratio has to be 5. So multiplying by 5 is what gets us the 35, and that works for this one here. For the last one, to go from 400 all the way to 50, we times by 1/8 or divide by 8. We have to break that into 3 jumps, so you need to cube root. So that's timesing by a half or dividing by 2. Well done if you managed to get on to those trickier questions near the end. Here are 2 GCSE questions from AQA about geometric sequences. Have a think about them, and then we'll talk through the answers in a couple of minutes. Okay then, here is the thinking behind the answers for these 2 questions. So for the first one, we're given the formula for the nth term as 2 times 3 to the n. Now, the formula for the nth term tells us the values in the sequence for different terms where n is the term number. So if I wanted the first number in the sequence, I would put n equals 1 into that formula. So for the first term, I'm doing 2 times 3 to the power of 1, which gives me 6. For the next one, I'm using n equals 2. So the second term of the sequence is going to be 2 times 9, which is 18. Looking at the list of numbers they've given us for the multiple choice, 18 is one of them, and we've just shown that 18 definitely is in the sequence, so we can cross that off as one of the possible answers. For the third term of the sequence, we're going to be doing 2 times 27, which is 54. Again, we've now shown that it definitely is in the sequence, so it's not going to be one of the answers that we need. Let's find one more term of the sequence so we can get a sense of how it's doing. 2 times 81 is 162. So if we now write that out as a sequence, we've got 6, 18, 54, 162, and as we progress onwards, we would be timesing by 3, so the sequence would be getting bigger and bigger and bigger. So looking at our 2 remaining answers, 152 is definitely not going to be later on in the sequence because 162 is already too big and we're going to be getting bigger and bigger and bigger. 152 is going to lie in between the third and fourth term. So we know that 152 isn't in the sequence. If you wanted to, you could times 162 by 3 and you would get 486. So you could confirm it that way as well. So for this question, we need to have a look carefully at each of these sequences and decide which one of those is geometric. So you need to remember here that for geometric sequences, they have to multiply as they go along. All of our sequences begin with 1 and then 2. So thinking about going from 1 to 2, if it were geometric, we'd be timesing by 2 as our common ratio. So we need to have the sequence 1, 2, and then continuing by doubling every single time. And the sequence that does that is this one here.